Hey everyone, this is Matt with Learn Everything About Design, and in today's video we're going to be using the Creality CR-Scan Otter to scan a couple of parts. Now we've already done a review on this scanner and I wanted to do a follow-up where we walk through actually scanning an entire part and processing the mesh so that we can use it in 3D CAD. So what we're going to take a look at today is going to be this black triple clamp, which we've seen several times in different videos. Now I've mentioned that the CR-Scan Otter did really well with this part and something that's a lot of other scanners on the market really can't do. But we're going to take a look at another black part as well. We're going to be taking a look at this gas cap. Now this gas cap is plastic, it's black and it's sort of a matte finish and it has an orange piece on the inside. So with both of these models, we're going to take a look at the scan settings. We're going to understand how to prepare our area for scanning and also how to process the mesh afterwards by combining multiple meshes together. So let's go ahead and get started first on the triple clamp. In order to prepare to scan these parts, we really need to just think about how we're going to set them up when we start scanning. Now, one of the tricks that I use with these scanners is I try to get the first scan perpendicular. That's going to help with alignment when we actually get into processing it inside of Creality Scan. But for a part like the gas cap, we're going to do it in a single orientation like this, get as much of the detail around the top as possible. And then we're going to try to get the bottom. Now, because I still have the vent tube on the top of this, I would need to use something that I can set it on, maybe a tall socket. That would be certainly fine. Or we can just set it down and we could scan it at an angle and then flip it over and scan it at another angle. But you really want to make sure that you have good range and angle as you're going all the way around the part. The other part for the triple clamp, as I mentioned, generally we want it to be off the platform just a little bit. There are options for us to remove a table when we're scanning, but in this case, what I'm actually going to do is take the bar clamps from the top side. They don't fit perfectly, but they fit just enough on the bottom that I can use them as standoffs. The way that KTM does these, they're actually offset. So I just need to offset them on the short side and make sure that I bind them just enough so that I can set this up and have it be raised up off the area. The other thing that we want to do is have these sort of paper towel or paper crumpled pieces scattered around random places. Now I'm using the black mat that came with the CR-Scan Otter. Doesn't have any marker dots on it, but it helps sort of give a good contrast between these small white pieces of paper. And we want these sort of around. And what that does is it helps us with these features on this mat. So as we go around the outside, it'll help capture those details a bit easier. You can place them on the part, but just note that it's going to be a little bit more difficult for us to remove those later. So in most cases, I just try to place them in random places around the object, so that way I could capture it. We're going to be scanning this in medium size object mode, which means that the scanner is going to be pretty far away, and it'll capture almost all of the clamp in a single frame. And with this part, we may end up doing it in medium, or we may end up doing it in fine. I haven't quite decided yet. We'll just have to see how it works out. Now that we have everything sort of ready to scan, I have a couple of other things in here. Sometimes I'll use sockets. These are black impact sockets, but we can also use chrome ones because those won't really get picked up by the scanner. Sometimes you can use these to stand your objects up a little bit higher, and that will help so we can get around the bottom side, around these lips. With this gas cap, it sits up off the ground or off the table, in this case by itself, so we don't really need these. But it's handy to just have little things like this around and make sure that they are the same height if you're using multiples. Once we have Creality Scan started and the scanner is hooked up, which we've talked about before on other scanner videos, all we really need to do is start a new scan. We need to give it a name, and I'm going to call this KTM triple clamp, and let's go ahead and make that R lowercase. And then we need to come up with our settings. It looks like I may already have one called this, so I'm just going to add video to the end of it. I'm going to use the medium object size. For a part like this, any critical features I would measure, so I'm not too concerned with actually capturing those small fine details. We're going to do high quality, no turntable, and normal object mode. So from here we can select scan. I generally like to go in and use manual exposure. And then we'll grab the scanner and use the plus and minus on the scanner itself to get to a good exposure level. We do want to pay close attention to the distances, the move closer, move farther, and optimal. With medium scan mode, we're sitting at about 10 to 12 inches away from the object. If we go any closer, then you'll notice our exposure value is going to kind of be a problem. You can start to see those red highlights on the corners, and the preview in the center of the screen shows that they're not being picked up. So we do want to make sure we get that exposure value right. And once we're happy with this, go ahead and hit play and start capturing. The first thing that I want to do is capture one side, and I also want to make sure that I am picking up those paper towel markers. Those are going to be important as we go around the outside corner. Now you can see that we're capturing at about 11 frames a second. The 11 frames a second will change if we're using small mode or large mode, if we're using fast or high accuracy. You'll see a fluctuation in those values. With objects like this, we're generally going to see somewhere between 15 and 20 frames a second as being pretty average. I don't think you're going to get much more than about 20 frames a second on medium or large scans. So everything's looking good so far. I'm just gradually moving in and out, even though I'm outside of the optimal range. I just want to make sure that I am capturing the geometry. If we lose tracking, just move away until you can see some of those paper markers. And we're going to just sort of work our way around the outside here. Again, trying to get as low as possible. This is where having it spaced off of the table or workbench is important, because we can get down to that bottom edge, capture as much detail as we can there. We are going to flip the clamp over. And I've noticed with dark objects, I tend to focus on the RGB preview in the bottom left. That seems to be a little bit easier than the top left, which these darker objects, the exposure value really isn't helping us out much. So we can't really see what's going on. But just move around, trying to keep the object at a perpendicular angle and just move around slowly. Now I could likely go faster than this, but taking our time, especially when we're capturing data that has potential problems because of these circular features, is going to be important. So just work your way around. Make sure that you are trying to keep some of those little paper towel pieces in view, and that will really help out when we're talking about the automatic alignment during scanning. All right, you can see everything is turning green, and that's a big thing that we want to make sure we understand when we're using the Creality Scan software. When we see something that's red on the screen, that means we haven't really captured enough points or enough data yet. It really has to be a good, bright, rich green. And once we get that green color, that means we've got enough where we can build a clean point cloud and a clean mesh. One of the differences between the way that Creality does things and some of the others is once we get this into the software, or once we start processing it, what we're actually doing is we're going to refine what we see on the screen into the point cloud, and then we're going to take that point cloud and turn it into a mesh. So there's a couple steps to this process, and right now what we're looking at is just a preview of the collected points. It's not actually the raw point cloud data. But make sure that we capture as much as we can. The insides where this actually clamps onto the forks is going to be fairly difficult, but we want to do the best that we can to capture that data. Again, moving around, trying to keep the scanner at a perpendicular angle. Because I can't see the back of the scanner anymore, it can be kind of tricky to know whether or not we're actually in the right area. If you happen to capture extra data, you can always go back and use undo. We're going to undo just a couple of frames. And then we're going to go back to where we have good alignment. Hit play. And we'll let it try to figure out where it is in space. Again, here's where the little pieces of paper towel help, because that's really going to help it figure out where the part is in 3D. And then we can move around and again, try to capture a bit more data. I want to do as good a job as possible getting into the bores where the fork is going to clamp. But we have to realize that that's an area where instantly we're going to have a potential problem with the alignment. As soon as it gets to a true circular feature, it tends to lose a little bit of that information. and it starts to either spin the part around or go a bit crazy on the screen. Now, of course, we can pause at that point and we can do our best to undo those frames. But if we just take our time and go slowly, generally we get a pretty good result. Some of this we'll be able to get when we scan the underside as well, but let's just take our time, try to get into those dark pockets. One thing I mentioned is scanning into deep pockets, like the bottom side of the clamp. That is actually something that a laser scanner can do much better, something like the CR-Scan Raptor, whereas an IR structured light scanner really isn't going to do very well. It looks like we may be missing a bit of information there on the back side here, so I want to try to capture that before I finish this scan. Let's go ahead and get back to a position where we think it can figure itself out, and I'll work my way around. Again, trying to keep those small paper pieces in frame. That's going to help it know where it is in 3D space and work its way around the back. So remember, scanners work best when the scanner is perpendicular to the surface. And what I mean by that is we want it to, the depth cameras really work best when it can bounce directly back from the object to the scanner. If we're at an angle, a couple degrees, it'll be okay. But if we're at a pretty steep angle, it really can't capture that data. So everything looks like it's okay. I'm gonna see if I can work my way forward, try to get inside of that front section where the fork is clamped, and I'm gonna call it good there. All right, I think that's good. So I'm gonna hit stop to complete the scan. And once we have our first scan, I'm not gonna process it on the laptop. It does quite a bit better on my desktop. So I'm gonna come over to New Project. We're gonna put it in the same project name using all the same settings and add a second scan to our project. Once again, I want to go to Manual Exposure Mode, and the bottom's gonna be a little tricky simply from the fact that it has dirt and dust in it. And that's gonna mess with it a little bit, but also the fact that we have these deep pockets, it's really not gonna do a good job with the deep pockets. So what we're gonna do is we're gonna loosely put these in just so that the bolt is below the top. And we'll do this one as well. And then we'll flip it over. All right, now we can set our exposure and make sure that we're at a good distance. I'm going to try to go a little bit higher on the exposure, which could potentially be a problem, but let's give it a shot. We can always adjust the exposure on the fly as well. If we feel it's too high, I can hit minus here. So when we get to those areas where there's dirt and potential problems, we can always just play around with the exposure until we capture the data. Since we're adding the clamps or the bar clamps to the top and the bottom of this, that's going to be a difference between the top and bottom scan. And we need to make sure that we remove those before we try to align the scans. That's something that we need to keep in mind when we get to the next step of this process. But right now we just want to go slowly. Once again, stay a good distance away. Try to keep all the features in sort of in view of those little paper towel pieces. You could, of course, use markers, but I don't like to use markers if I don't have to. One, they're expensive, and two, you have to remove them, not only from the part, but you also have to remove them in the software. So if you end up putting enough markers to use marker alignment on here, you end up with a lot of markers on the part, and it's more of a pain to remove. So if you don't need them, you don't need to use them. All right, let's go ahead and move that out of the way. All right, looks like it's capturing okay. Once again, you can go faster than this. I'm going a little bit slower just because I want to make sure that I get everything to turn green. You will notice that there are some areas that it's not turning green quite as easily. But having those little paper towel pieces and having the clamps underneath, that helps let's go ahead and, here's where we're going to start to have problems. You can see it's already starting to spin around. So I'm going to flip this around. And I'm going to come back to here and I'm going to work my way around this way. Now, I didn't add any extra little paper towel pieces on this side, so I need to be very careful. Otherwise, it'll begin to spin the scan around on the screen. And then we're just going to be kind of lost with alignment. So try to make sure you do keep some sort of unique feature in the view at all time. Work our way around. You can see those 4 little pieces on the back. Once again, the key here is to make sure everything on the screen is turning green. Anything that's red is not enough data, and once we start to process this and turn it into point clouds, it's going to be filtered out and removed. So make sure that you do take enough time to make sure everything turns green that you want. Now, if you're just trying to do a quick reference model, you don't necessarily need as much, but if you're trying to take this into CAD and maybe create a new variation, a new version of it, then you definitely want to take your time and get more scan data than you think you need. Now, I did have a question recently on one of the videos if the accuracy and precision of these could be used for CMM. Now, CMM is basically a high precision measurement. Now, CMM is typically used after you CNC machine parts or manufacture parts to validate their sizes. And no, I don't think that we could use this scanner or really any of these consumer type scanners for that type of work. It's just, while you can get plus or minus 0.02 millimeter accuracy, it's not going to be to the level where you can use this as an inspection tool. And also something to consider is you really need additional software to do inspection. Inspection is something that is fairly unique. And there are, of course, pieces of software that are dedicated to that and based on 3D scanning software or 3D scan models. And Creality doesn't have anything like that. And they're not really in that segment or that market. Maybe in a couple years, 10 years, we'll see that happen. But for right now, you need to spend quite a bit of money on both hardware and software to have something that would be capable of doing metrology grade scanning. Now, I know some of you will say, well, you know, on Creality's website and other websites, they say metrology grade. That's really coming down to the numbers. So if we look at the accuracy, the precision, the resolution, those numbers are where those figures come. When they say metrology grade, they mean plus or minus 0.02 millimeters, and that's considered metrology grade. That still does not give you the ability to do things like part inspection. You need additional software to do that. We can talk about that on the channel, but it's not generally something you do with these hobby scanners. And I call them hobby scanners because really, when you're spending $800-900 for the CR-Scan Otter, that's different than spending $20,000, $30,000, $40,000 for other scanners that are considered metrology grade and professional. So it's just a different segment. Same thing with 3D printers. When we are talking about K1 Max, it's a great printer. The K1, K1 Max, K1 Carbon, these are great 3D printers. They are different than if you were trying to invest in, say, an HP multi-jet fusion printer, right? You're talking about spending $1,000 versus spending $50,000 to $100,000, right? They're not quite in the same sort of arena. They have different end case users. I think we've got more than enough, but there is definitely a problem trying to get into these pockets. The pockets are obscured by the clamp itself, and it's not something that we're able to do. So one thing that we're probably going to have to do is leave those open when processing, and we could manually fix them. But if I zoom in here, let's see, let's rotate this around. So basically what we're seeing is we can't get this face right here because the clamp itself is preventing a straight line to go into those pockets in those areas. But I think we've got enough that we can put together two models. So I'm going to say stop and complete the scanning. Now from here, I have both of those scans. I'm gonna go to my desktop to process them. So we're gonna go back to the home page. I'm gonna put this off to the side. And we'll just take a quick look at the gas cap. Now, as I mentioned, you generally want to possibly raise this up. We're gonna start a new scan. I'm gonna call this one gas cap. We're gonna use the medium object, all the same settings. And once again, I prefer manual exposure so I can control it rather than having the software figure it out for me. So we'll increase that. And the orange section in the center is gonna be a problem, so we're likely gonna have to tweak this on the fly, but I really wanna capture the black areas. So may need to drop the exposure down and see what we can do. There we go. So with something like this, we need to go slow until it captures enough data that it can find itself in 3D space. The fact that this is raised up off of the table is probably making it a little bit more difficult, but once we capture enough that it knows where it is in 3D, it'll help us out. But in the initial run, it makes it a bit more difficult because it has to figure out it's not sitting on anything. It's kind of raised up in 3D space. And we can just, once again, move around, trying to keep those little paper pieces in view. The paper pieces are really a key to this process. So we don't have to use markers. Just work our way around the backside. And once again, I can't stress enough that when we're scanning, the scanner really needs to be perpendicular to the object. So we can't just keep it at the same orientation the whole time, especially if we're going around a round object. We need to try to move and keep it pointing in the right direction. And keep in mind that we've got these sort of face and surface features that we need to capture perpendicular to their geometry. Now, I don't really care about the vent cap on this. I could have pulled it off, but it's just going to be a reference because the tube is actually bent a little bit. What I mean by that is it's kind of skewed to one side, and that'll also help it a little bit with alignment. So just kind of work our way around. If we could get this in a single scan, it would certainly be beneficial, but we're going to do 2 scans. All right, I think I've captured everything. The socket will have to be removed, of course, but I think I captured everything. So let's go ahead and pause this and just take a quick look. Looks like I could maybe use a bit more on the front side. So I'll go back to a front view where it can find those pieces of paper, start the scan again, wait for it to find it. It is important that the pieces of paper are different sizes and different orientations. That's going to be a big part of making sure that it knows where they are in space. I'll work my way around just a little bit. Pause. And we'll call that good. Right now, I'm really only concerned with the top. And then we'll add a new project. All the same settings for right now. And I am gonna try to scan the bottom. This is going to definitely be tricky. Let's go ahead and make sure that we are using manual exposure. The bottom is going to be tricky. It's a lighter color than the black. So again, we'll probably have to play around with the exposure on the fly. Make sure that we do get those pieces of paper so it doesn't try to rotate. And get the bottom first. Get the bottom first and all the pieces of paper so it has those references, and then work our way around. This piece is actually multi-piece assembly. We could take it apart and scan all the individual pieces, but for right now, that's not an option. Just gonna leave it together. I do want to note also, and I'll mention this when we get to processing, in talking with Creality about options in the software, I asked them about the ability to align multiple scans, which it can do, but allow the user to not merge the scans together. And they mentioned that they are working on that, and they had said that it'll be in the next release of the Creality Scan software. So they are actively improving the software, and I know I've mentioned in other videos, that's really the big thing holding the Creality scanners back. The hardware is great, the software is what's lacking compared to other options on the market. But they are actively working on it, which is great news. So if you do have a CR-Scan Otter, or if you purchased one of the new Raptors, or if you're using something else like the Ferret, then just know it sounds like those things will be getting better. Do want to also remind you, we are now a Creality affiliate. So if you are purchasing a scanner, you can use the link in our description, or anything from Creality, and it does help out the channel. So far everything looks good. We are going to flip this around and do a secondary scan. But for right now, I want to capture as much as I can. I need to get some of the data on the outside so it has the ability to align. Because this does have a repeating feature, it is going to be a bit tricky. So do make sure you work your way around, capture what you can. All right, let's pause there. Stop, and we'll get one more scan before we take this up to the desktop. All the same settings, just flip it over. Once again, we'll use manual exposure. If you like to use auto exposure, that's perfectly fine. I personally have found that I prefer the ability to use manual exposure on the fly. It seems to give me better results, so it's kind of what I like to do. Once again, these first couple of frames, stay fairly still and just try to get all the little pieces of paper around the object. Once we at least have those references, that will help with tracking in 3D, and then we can begin to work our way around. The main thing that we need to capture here is going to be the outside frame. I think ultimately we're going to have to do these 3 scans together in order to get a complete cap. There will still be holes again because these types of scanners, whether it's blue structured light or IR structured light, they aren't really good at scanning down into cavities. So these pockets and areas where they're kind of occluded. A laser scanner really does much better with something like that, whereas a scanner like this, or pretty much most of these scanners on the market, they just don't have the ability to get down into those areas. And let's see if we can get back to their alignment. All right. I think at this part we're probably good. In general, I say that you always want to capture more than you need. And that's universally true. It's much easier to capture more scans now than later on and have to come back. But for right now, I think we've got enough. The first scan is really the key, making sure that we got the entire top. And then the 2 scans on the bottom, we'll have to merge everything together to make that single version. But now that we have this, let's go ahead and take it to our desktop. So now we're at the desktop, we can begin to process the scans. Now, it should be clear at this point that everything we did in the garage was real time. Nothing was sped up. That was the entire time it took to create those scans, set everything up. And obviously, without narrating, it can be done quite a bit quicker. But what we're going to do is now open the projects because I have them saved. So I just need to go to where I save them. And we're going to start first with the triple clamp. Select the OBP file, which is our project file, and this should open up both scans, the top and the bottom scan. Now, once I mentioned this in the garage, but it's important to note that with Creality, the first step in this process is not truly the raw point cloud data. If we zoom in, what we actually are seeing is a very well-structured, it's probably going to be impossible to see on the screen, but we're seeing a very well-structured set of points. And what we need to do is we need to sort of optimize that. So the first thing that we're going to do is get rid of some of this data. There's stuff hanging out here. So we're going to use the lasso, hold down Shift and the left mouse button, and just start to clean things up. There are a couple of ways that we can do this. You can in the scan itself, you can turn off the option to capture a plane. Now, if you set your object directly on a table, that can be extremely handy. Because ours was raised up a little bit, it does present some different challenges, but it's pretty quick for us to get rid of most of this. The clamps themselves, the little bar clamps, should not actually touch any of the mesh because we didn't scan the underside. So again, that stuff should be pretty easy to remove. Just go ahead and try not to take away too much. If we have got some straggling points, it's not a big deal, but rotate it around, make sure that everything looks pretty good. Now that we've got this, the next stage in the process is to optimize. I'm going to use the manual settings. I'm going to take the resolution down to 0.1. Remember that we were scanning on the medium size. If you go down to the small size object, the resolution will be able to go smaller than 0.1. In this case, 0.1 is as small as it will go. When we talk about the sensitivity, and again, this is one of my gripes with Creality because it doesn't really give us a lot of options compared to other software. We really only have these two sliders, the resolution and the sensitivity. But the sensitivity, when it's higher, will retain more of the captured points. If we set this lower, it will be able to filter out a lot of those points. We have to be careful with this step in the process. Unlike other scan softwares, we end up when we do things like merge the scans together, the original data is deleted, it's lost, at least to the best of my knowledge. In talking with Creality, I mentioned trying to do alignment of multiple scans, and in those instances, we don't want to remove the original scan data and we don't want to merge it. They are working on that, and they told me that it would be in the next release of the software. So that's great, and that allows us to do things like, in the case of the Xbox controller I posted about, scan the controller with the battery door, scan the controller without the battery door, and scan the battery door on its own. And then we can have a mesh that we can use to align both of those pieces. So we can have the original scan that would align the battery door with the controller. And then we can also align those individual scans, process them, and export them on their own. That way we've got them aligned to the same coordinate system, theoretically. And when we actually go in to do some CAD or some design work, then we'll be able to have individual mesh files rather than just having one all merged together. Now, the scan capture part of this process and everything that we do here, I'm going to leave at real time, with the exception of this optimizing. Depending on the number of points that you're dealing with, and here we've got 3,400 frames and about 44,000 points. Depending on what that number is, it's going to take a differing amount of time to optimize. So in this case, we're at 45% and it's been a couple minutes. Probably looking at 3 to 5 minutes to process this. So we're going to go ahead and pause and we'll check back in after this one's processed. All right, so it's done now and we can see it looks pretty good. We have a lot of detail. We can see the part number here. Now this is a 22 millimeter offset clamp. We can very clearly see 22. And remember, this was done on medium. It wasn't done on the smallest scan setting, which has the highest level of detail. This was plus or minus 0.1 millimeter resolution, not the plus or minus 0.02. We need to do the same process for the backside. You can see areas where we maybe didn't have enough data. And during the scan process, it was mentioned that these are areas that are hard to get to, little areas where they sort of self-shadow. It's generally called ambient occlusion, but those areas are more difficult. So what we need to do now is just repeat the process. Again, I'm going to keep everything real time. It doesn't really do us any good to speed everything up. So I'm going to do it real time until we get to that processing. Let's go ahead and zoom in here. When we see points floating out in space like this generally happens when the exposure setting is too high, like we have a lot of red on the face of our part. And what ends up happening is those are essentially reflections bouncing off the part. So it gives us this sort of this problem where the points are not where they're supposed to be in 3D space. So that's what we want to avoid, and that's kind of, again, another reason why I use manual exposure. It allows me to take care of that manually, and I don't have to worry about those points. If there's something I need to capture, I can raise or drop that exposure level manually. I don't really need much in the way on this bottom section. We really mainly are looking for enough overlap on the side that we'll be able to align multiple scans. So again, clean this up. And if there are some points floating in space, so there's like a point here, that's going to get filtered out automatically. Really, the main area that I'm worried about is inside of these pockets. As I mentioned, the clamp is sort of self-shadowing. If we look at it from this view, there is no way that the clamp or the scanner could see down into that pocket because the angle it would need to be at would be looking through the inside of this corner. But let's double check our settings. And it looks like I maybe clicked a bit too quick. But what we want to do is we want to double check those settings and make sure that we optimize properly. So I'm going to pause this and we'll check in once this one's optimized with those same settings. All right, now we can see that it's done. There are obviously a few areas where we're missing data, and that's okay. We don't need it to be perfect. If you are looking to get into all these areas, then using an IR structured light scanner is just not going to work. You really do need something like a laser scanner, and hopefully the Scan Raptor is something that would be able to do this. And once we get our hands on it, we will try to rescan this part. But right now we've got point clouds optimized at the same level for the bottom and the top. And what we're going to do is we're going to try to combine or merge these together. What we need to do is come over to the right side and talk about point cloud merging. So when we have point cloud merging, there's two main ways, auto and manual. The auto method I found is actually pretty darn good. So what we're going to do is select both scans and select start. Now, hopefully there's enough data here for it to be able to find a solution, and it happens relatively quickly, but obviously this isn't right. Now you can see this clamp area should be on the bottom, and it's basically on the wrong side. It's using this reference here, which is okay, but it's incorrect. So we're going to hit cancel, and we're going to go to a manual option. So fixed window 1, we'll select scan 1. Fixed window 2, we'll select scan 2. So we're going to rotate this around. And one of the potential issues here is going to be our references. So what I want to do is I'm going to try to align these in the same orientation, like this. And one thing that it got wrong is it assumed the geometry here, this sort of ball end mill that was run here, was the same on the bottom, but it actually ends flat here. And we can kind of see that if we rotate this around. So it didn't quite have that data. So what we're going to do is we're going to start to pick some points. So I'm going to pick a point here at the top in this fixed window and here on the top over here. So just like when we're drawing a box and trying to select geometry, we have to hold down Shift and click to place a point. And then we'll do the same thing over here, Shift and click. Then I'm going to zoom out on both of these, and we're going to rotate around, and we're going to come to right about the point where we get into this section around the fork, and that green dot will go there, and a green dot will go there, and we'll come over to the other side, maybe zoom out a little bit, and we'll place one on the bottom section here, so right around there, right around there. So 3 points is enough, but I'm going to rotate this around. And I want to give it some additional references as well. So we've obviously got this clamp area here, and I want to give it a reference in here that's in about the same location. So we're going to shift click and left click here, and we'll place one here. And hopefully these will give it quite enough points. So let's go ahead and hit start. And now let's take a look at the merge results. Now that's looking quite a bit better. So I'm happy with those results. The orientation is good. All the parts look like they're in the right place, so we can say yes. It's going to optimize this. It's going to go through, and what it's going to do is create a merged point cloud. And once we're done with our merged point cloud, we can hit exit merging page, and what's left is our component. Now the component is a merge of scan 1 and scan 2, and this is where I had a question for Creality. Basically, what I was hoping for was the ability to not merge these and optimize them, and they're working on that. You'll notice that there is a potential problem here. We kind of filled in that area of the clamp. Not a big deal. We can still do some manual modifications if we wish. If we go to this lasso, you can see that there is a rectangle select. And if we rotate this around, we can maybe get to an orientation where we can do a rectangle select, probably from the top. Let's see if we can rotate it. Right, maybe zoom in. And see if we can maybe cut that out. Can hit delete. And it's not perfect, but again, we're just cleaning it up. The next thing that we want to do now that we've got our point cloud, as we can see over here in the bottom left, is we've got the origin, which was the original raw data, the point cloud, which has been optimized, and now we need to move on to the mesh. On the right-hand side, we can determine the faces, the denoising, and whether or not we want hole filling. Now, hole filling is something that we can potentially do manually. If you turn this option on, this is different than closure. So what hole filling does is it's not trying to create a watertight mesh, but what it is trying to do is fill in any potential gaps there is inside of our point cloud data. Where this is going to be a problem is that we've actually got some pretty big holes and open areas here. I don't know how it's going to handle that. I've actually not done this before. We're going through this real time live. This is the first time that I've scanned the clamp in this way. So what I want to do is think about my options. We've got faces and denoise. Denoise will allow us to do some smoothing, but you'll notice that this goes from 0 to 3. I'm going to put this at 1. I don't want to do a lot of processing here. I just want to do a little bit. And I can limit or try to get to a specific number of faces. This is always a tricky one, but I found that you really don't want to crank this thing all the way up. You want to keep it into a fairly low number if possible. Because keep in mind that here we're already at 1.25 million faces. So if we can get it to be as low as possible, that's going to help us downstream when we take it into Fusion or SolidWorks or something else. So let's go ahead and click Process, and we'll see what this thing looks like. So one thing I do want to mention, I unpaused the video while it's meshing because it's actually going to take quite a long time. But one thing I do want to mention is that we are able to redo some of these steps. So after we go through the meshing process, we can remesh it. And like we did, or like I did with the point cloud, I did the wrong settings and I went through and I redid the point cloud settings to optimize it. But there is going to be a limit. There's a limitation to how much access you have to the raw data. This is why it's important that we capture as much and sometimes more or too much data at the scan time, and then we can have extra to play around with when we're processing. So now we've got a final mesh. One thing that we can see is kind of on the edges here, it looks a little bit rough. So what I'm going to do is go back to my mesh settings, and I'm actually going to increase the number of faces. This will allow me to capture more detail, and then I can do a little bit of work post-processing it to maybe do a remesh and try to preserve those sharp edges. So I'm going to do this one more time. Again, this does take a couple of minutes depending on your computer, but this will allow us to see a quality difference in the edges to see if we can capture a little bit more of that detail. All right, so now we're done. If we zoom in, we can see that there is still some variations in the edges, but that's what we were that's basically what we would expect with a mesh. We can continue to optimize this by adding additional faces and remeshing, but the process does take quite a while. Now, overall, I'm really happy with the results. I think there's plenty of information here that would allow us to reverse engineer this part. Obviously, there are some holes in certain areas, but we could get the locations of the bar clamps. We have all the information we need on the overall size, and we could take this into Fusion or a CAD program of your choice and begin to work with it. Now, what we're going to do in this video is we're basically going to stop with this part. I'm not going to go through the same process with the gas cap because honestly, it's identical. It doesn't matter if you're doing it with a triple clamp or a gas cap or something else. You still have the same process of going through and optimizing the point clouds, merging multiple point clouds together, either automatically or manually like we had to do, and then converting it to a mesh. Now, hopefully there'll be some updates in the future to the next version of Creality Scan, But what I'm going to do in the description of this video is I'll put links to mesh files that were done with the Otter, and that way you can take a look at them and get an idea as to what the resolution is and what the parts actually look like. Now, I'm really happy again with the medium level of detail, seeing the part number and the information that we have here. We certainly could have captured some of the other information better had we used the small option, which has 0.02 millimeter resolution. But for what we need with this clamp, I think the medium size object was more than enough. Now, if you have any questions on this process, please let me know. I've covered this software before, so we know at this point all we really need to do is export this mesh, and then we can bring it into Fusion or some other program, which again, we've covered on this channel many times before, and I don't really feel like we need to go into that over and over again. But if there are any questions on anything we did here, from the setup and scanning process to how we process the mesh here, and how we essentially work with the Creality CR-Scan Otter, please let me know. And once again, we are now an affiliate for Creality, so if you're purchasing a scanner or if you decide to purchase anything and you use the affiliate link, it does help the channel out, but there's obviously no pressure to purchase anything from Creality. Hopefully the information was helpful. If you do like this content, please consider subscribing to the channel and leave a comment on stuff that you'd like to see. We have lots of videos in the pipeline. A lot of comments have come in on things that you all want to see, and we're doing our best to get to everything, but it is quite a long list at this point. But please feel free to leave a comment. Let me know what you want to see. If it's something that we already have in process, we'll be sure to add it and maybe bump it up the list. But as always, thanks for watching, and we'll see you in the next one.